Hello everyone. In this video, we are going to learn how to calculate the sample variance and the sample standard deviation of grouped data. More specifically, we will look at what grouped data means, how to find the midpoint of a class interval, how to calculate the mean of grouped data, and then how to use all of this to find the sample variance and the sample standard deviation. Let's start straight away. What is grouped data? Grouped data means that the data has been organized into groups, classes, or intervals. Let's look at this example. We have a survey conducted among 40 students, and we are looking at how many minutes they spend revising maths each day. In the table, the first column is called class interval in minutes, and the second column is the frequency, which we write as F. The first class interval is from 10 to 19 minutes. This means we are looking at students who spent between 10 and 19 minutes revising maths each day. In that same row, the frequency is 3. So this means that 3 students spent between 10 and 19 minutes revising maths each day. In the next row, the class interval is from 20 to 29 minutes, and the frequency is 5. So 5 students spent between 20 and 29 minutes revising maths each day. This is how we read the table. Our goal is to calculate the sample variance and the sample standard deviation for this grouped data. To do that, we will follow these steps. First, we find the midpoint, which we write as x for each class. Then we calculate fx, which means the frequency multiplied by the midpoint. After that, we find the mean of the grouped data. The mean is written as x bar. Then we find the difference between the midpoint and the mean. Next, we square these differences. Then we multiply each squared difference by the frequency. Finally, we calculate the sample variance and the sample standard deviation. Here are the formulae we need. For the midpoint, we use x is equal to the lower limit plus the upper limit, all divided by 2. For the mean, we use x bar is equal to the sum of fx divided by the sum of f. For the sample variance, we use s squared is equal to the sum of f times the squared difference between the midpoint and the mean, divided by the sum of f minus 1. To find the standard deviation, we take the square root of the variance. In these formulae, f is the frequency, x is the midpoint, and x bar is the mean. I recommend grabbing a pen and paper, noting these formulae down, and trying to solve each step actively as we go. Understanding the method is important, but maths becomes much clearer when you actually do the steps yourself. So try to calculate each part as it appears on screen. At the end of the video, there will also be a similar question for you to try on your own. Let's start with the example. A survey was conducted among 40 students to find out how many minutes they spend revising maths each day. Find the sample variance and the sample standard deviation. We have grouped data organized by class interval, and each class interval has its own frequency. The first thing I recommend doing is extending the table by adding 6 extra columns. The midpoint, x, fx, the mean, x bar, x minus x bar, the square of the differences, and f times the square of the differences. Once we have these columns, we can start filling them in step by step. Calculator ready, and let's start. We start by filling in the midpoint column. The midpoint is the middle value of each class interval. For the first class, the interval goes from 10 to 19. So we want the value exactly halfway between 10 and 19. To find it, we use the formula. X is equal to the lower limit plus the upper limit, all divided by 2. For the first interval, this gives 10 plus 19 divided by 2. 10 plus 19 is 29. 29 divided by 2 is 14.5. So the midpoint of the first class interval is 14.5. We write 14.5 in the first row of the midpoint column. Then we use the same formula to find the midpoint of each remaining interval and complete the column. The next column is fx. This means that in each row we multiply the frequency by the midpoint. For the first row, the frequency is 3 and the midpoint is 14.5. So we calculate 3 times 14.5. This gives 43.5. We write 43.5 in the first row of the fx column. Then we use the same method for each remaining row and complete the column. Once the column is complete, we add all the values in the fx column. The sum of fx is 1,580. We also need the total frequency, so we add all the frequencies, 3 plus 5 plus 10 plus 13 plus 9. This gives 40. This also matches the question because the survey was conducted among 40 students. We can now calculate the mean. For grouped data, the mean is x bar is equal to the sum of fx divided by the sum of f. So here we do 1,580 divided by 40. This gives 39.5. So the mean is 39.5. This is one mean for the whole dataset. It does not change from class to class. So in the mean column, we write 39.5 in every row. The next column is x minus x bar. For each row, we take the midpoint and subtract the mean. The mean is 39.5. For the first row, the midpoint is 14.5. So we calculate 14.5 minus 39.5. This gives negative 25. We write negative 25 in the first row. Then we repeat the same process for the rest of the column. In this column, some values can be negative and some values can be positive. That is completely normal. A negative value means the midpoint is below the mean. A positive value means the midpoint is above the mean. The next column is the square of the differences. So we square each value from the previous column. For the first row, we have negative 25. Negative 25 squared is 625. We write 625 in the first row. Then we use the same method for the rest of the column. Important point here, in this column, all values must be positive because we are squaring them. So if you get a negative number here, check the calculation again. The final column is f times the square of the differences. So in each row, we multiply the frequency by the squared difference. For the first row, the frequency is 3, and the squared difference is 625. So we calculate 3 times 625. This gives 1,875. We write this in the first row of the final column. Then we use the same method for the rest of the column. Once the column is complete, we add all the values in this final column. This gives 5,600. This is the value we need for the numerator of the sample variance formula. Now we are ready to calculate the sample variance. We use the value we have just found, 5,600. This is the numerator of the formula. The total frequency is 40. So we calculate 5,600 divided by 40 minus 1. 143.58974336. Rounded to 2 decimal places, the sample variance is 143.59. A small calculator tip: try to round only at the end, so your final answer is more accurate. To find the sample standard deviation, we take the square root of the variance. Using the full value from the calculator, this gives approximately 11.98. So our final answers are: the sample variance is approximately 143.59 minutes squared, and the sample standard deviation is approximately 11.98 minutes. Now it is your turn. Try this question and find the sample variance and the sample standard deviation. Pause the video now, solve it using the same method, and then press play to check the solution. Here is the completed solution. The sample variance is approximately 158.62 minutes squared, and the sample standard deviation is approximately 12.59 minutes. I hope this video helped you. If you found it useful, leave a like and consider subscribing to the channel. Thank you for watching, and I'll see you in the next video.